Inshallah. Okay, let us to go back to the previous section where we spoke last time about the triangle inequality. And the last thing we have done that the absolute of the or the modulus of the complex number z, it will be denoted by when z is equal x plus iy. The modulus of z is equal to the square root of x squared plus y squared. And we have done some examples. هلا المودulus z we can will measure for you the length of the vector which is represent the complex number z, as we said last time. For example, when we have z1 and z2 be two complex numbers like this one here in the graph, this is z1 and this is z2. If you added z1 and z2, it will be the curve like this one here. So you will get a new complex number, which is the red color here, represent this new complex number, I mean the vector. الآن المودulus لا z1 plus z2, which means the length of this vector in red color, it will be less than or equal the total length of the first vector and the second vector, which is represent z1 and z2. And that's true, of course. يعني the length of the vector here in red color, it will be less than or equal, but for sure most of the time it will be less than. الآن we have inequalities or properties for the modulus, that the first one, المودulus for modulus z1 minus modulus z2 will be less than or equal modulus of z1 plus z2, and this one from the first triangle inequality will be less than or equal modulus z1 plus modulus z2. And second property, modulus of modulus z1 minus modulus z2 less than or equal modulus of z1 minus z2, which is for sure here this is less than modulus z1 plus modulus z2. الآن there are many properties are satisfied from the real number system to the complex number system. There are many properties which is hold in between, but there are some properties which is not applicable with the complex number. For example, we cannot compare the two complex number z and w by means of inequality. I mean, in complex number, I cannot compare two complex numbers باستخدام المتباينات. In other words, the statement, if we said that z is greater than w or z less than or equal w, this statement in complex have no meaning, except in case the two complex numbers z and w are real number. But we can compare the absolute value of two complex numbers. For example, when we say that modulus z less than modulus w, that means the vector of z will be closer to 0 than the w. I mean, z here will be closer to 0, which means the length of the vector which represents z will be less than the length of the vector which represents w. It means the complex number z will be closer than to the 0, I mean the origin here, than the complex number w. And this is section 17.1 already done. We will go now to section 17.2. 17.1 is already done, which is just the definition of complex number, how we can add it, subtract, multiply, and divide, and the conjugate, and some properties, and the modulus, and the vector representation of complex numbers, which is straightforward and simple. Now we will go to the second section. All the chapter of complex number are very simple and straightforward, just a matter of simple calculations. And in this section, we will learn how we can write the complex number in polar form. How we can write the complex number in polar form. This is our main goal here. الآن الهدف الرئيسي لنا هون كيف نكتب الكومبلكس نمبر بالبولار فورم and how we can find the powers and the roots of the complex numbers. الآن let us to recall that the point, if we have in real number, this point here in the xy plane, if it is located somewhere here, if you make a projection to the x-axis, this is the distance x and this is the distance y. Now, if you make the shortest distance between 0, 0 and this point here, this side, the hypotenuse becomes a hypotenuse of triangle, created an angle theta with the x-axis. Let us to call this one R. Now, I'm just recalling the polar coordinate for real pairwise or any point in rectangular coordinate. Here we have sine theta. It is y by r. That means y, it will be r sine theta. And cosine theta عبارة عن x على r. That means x is equal r cosine theta, where tan of theta here y by x, which means that theta can be represented as tan inverse of y by x in this way, which means that the polar coordinate system implies that the point xy here in the rectangular coordinate can be represented again by another coordinate called r theta, which is called the polar coordinate system. Of course, we have r squared will be square root of x squared plus y squared. R is a distance, so r it will be the positive square root. R it will be the positive square root of x squared plus y squared. And you remember the polar coordinate system from calculus 2. الآن we will find a way how we can represent any complex number in a polar form. How? Let us to see. I told you yesterday or in previous class, any complex number z is equal x plus iy can be plotted by using the two coordinates x and y. The two coordinates x and y. So here y is the imaginary part, or x is the real, x-axis is the real part. This is, we discussed this one yesterday. And you can create a vector, this vector r for this complex number. If you make a projection from this complex number to the x-axis, you will get this is x and this is y. الآن sine theta here, sine theta عبارة عن y divided by r, which implies in y is equal r sine theta. That's why I here replaced y to be r sine theta. Also, cosine theta بتساوي x divided by r, which means x is equal r cosine theta in this way. Therefore, if you replace this x to be r cosine theta, y to be r sine theta, and your complex number z is equal x plus iy, then z, it becomes now in this form. Z, it becomes r cosine theta because you replace x r cosine, will y to be r sine theta. If you take r as a common factor, so z, it becomes now in the form r is equal z is equal r times cosine theta plus I phi sine theta. Of course, you have to remember that from the polar coordinate, theta, it should be the angle where the complex number in the same quadrant of theta. I mean, theta should be in the same quadrant where the complex number is. We will discuss this one later on today in details, inshallah. Now, what about if the complex number z is equal 0? What about if z is equal 0? الآن, if z is equal 0, then x is equal 0, y is equal 0, so there is no coordinates. So it will be undefined. Therefore, when we are discussing about the polar coordinate of a complex number, that means z is not equal 0. Z is not equal 0. طيب, الآن, do you remember from previous class that r is equal to square root of x squared plus y squared? This is for the polar. If z is equal x plus iy, we said that modulus z, it will be square root of x squared plus y squared. We learned this one from previous class. So if you compare those, that means what? R, it is the modulus of z. So r here, this value r, it is can be replaced by modulus of z because it's the same value. And regarding the angle theta, theta represents the angle measured in radian. That is, z makes with the positive real x-axis. الآن, it should be the same quadrant. It should be the same quadrant where the complex number is. الآن, tan of theta is equal by x. This implies theta is equal what? Tan inverse y على x. I will learn you here now. What or how you can find the angle theta in case the calculator will give it to you outside the quadrant. It's very simple, just to add pi. إذن الآن this equation here, z is equal r cosine theta plus I sine theta, this is the polar form of the complex number. This is the polar form of the complex number. R, you know how you can find r, which is modulus z, which is equal to square root of x squared plus y squared. But theta, you have to find theta by using this identity or this equation to be tan inverse y على x, and it should be in the same quadrant where the complex number is. الآن, for the value of theta, we have two different concepts. The first one, it is called argument of the complex number z. What's the argument of the complex number z? Each value of theta is called an argument of z. And the set of all such values is denoted by arg z. يعني هذا الدefinition, small arg z, is the symbol of argument of z. But what's the meaning argument of Z? It means the set of all value of theta which is satisfying this polar form. Of course, you will have infinitely many values of theta. Infinitely many values of theta. Why? Because إذا كانت theta is equal argument of Z, then also theta plus 2 and pi is equal argument of Z. All the time, each time when you add 2 pi, 2 pi, 2 pi, you will get an argument, a new argument for the same complex number Z. So we have infinitely many arguments of Z. And we have another argument. It is called the principal argument of Z. It is called what? Principal argument of Z. But this one, it has a special meaning. The principal argument of Z, which is denoted by capital A. Capital A arg Z, that means the principal argument, is the unique value of theta, which is located between minus pi over 2 to pi, between minus pi to pi. How? Between minus pi to pi. شوفوا هون. To go from minus pi to pi, that means you have to go this direction. But why we did not put here inequality with the side of minus pi? Because if you take inequality with the side of minus pi, and we already took equality with pi, you will have double angle. Because minus pi with pi, you will get the same angle. الآن the value of the principal argument is called the principal argument of the Z, and all the time the principal argument of Z, it should be a unique value, يعني قيمة واحدة. الآن, what's the relation between small argument and the principal argument? The small argument is equal to principal argument plus 2 and pi. And all the time when you added n to be 0 minus plus 1, 0 minus plus 2, and so on. Okay? الآن how to compute the principal argument? This is the big question. It is very simple and very easy. You can calculate the principal argument. How? Let us to see. If the value of course, the principal argument, it should be between minus pi to pi, and with the closed side of pi and open side of minus pi. For any complex number Z is equal x plus iy. If the value of x is equal 0 and y is greater than 0, in this case, have a look what will happen. If Z is equal 0 plus iy, then it will be the complex number here, صح? So theta, it will be pi over 2. Z is equal 0 plus iy. The angle theta is equal pi over 2, or the principal argument. Okay? الآن, if x is equal 0 and y negative, in case x is 0 for the complex number z plus iy, and y is negative. In the complex number it will be here. صح? You need the principal argument between minus pi. الآن maybe some student he said, okay, why we did not get this one, which is 3 pi over 2. 3 pi over 2 is not belong to minus pi. But I have to go to the other way around, which is clockwise. In this case, theta is equal minus pi over 2. الآن, whatever the value of y is, we do not care, but in case x is greater than 0, just use your calculator and say that the principal argument is equal to tan inverse of y by x. Okay. الآن خلينا أكمل هون. What about if x is negative and y is positive? I mean, x is negative, it will be somewhere here. For example, minus 1. Y is positive. For example, y is equal to الكومبلكس نمبر بدي يكون عندي هون بهذا الشكل, صح؟ How we can find the tan inverse of y? The principal argument. It is tan inverse. When you use the calculator will give you the angle, this one here. This is calculator. But this angle in the fourth quadrant, but your complex number in the second quadrant. How you will get the angle to the second quadrant? Just added pi. So whatever the calculator will give you from tan inverse y على x, added pi. مين بيقول لي why the calculator will give you in the fourth quadrant when you take tan inverse pi by x?
Get a small argue.
لا يا طيب. لا. We have a nice connection with calculus 1.
دكتور ممكن عشان القيمة بتكون سالبة فبتطلع في الربع الرابع.
انت قربت شوي على الإجابة، يعني فكر فيها شوي بتطلع معك إجابة very nice. Do you remember when you studied this section tan inverse x in calculus 1? We put a condition that x it should be between minus pi over 2 to pi over 2. Hello, when we said that between minus pi over 2 to pi over 2, from where?
The first and the fourth.
First and fourth.
Yes.
That's what the calculator will give you. So how you, in case it is in the fourth, how you will move it to the second? Added pi.
Just add pi.
Added pi only. Type in case both of them are negative. I mean x is negative, well y negative. This is the complex number here. El calculator when x is negative, y negative. El calculator when you divide y by x, it becomes positive. So el calculator will give it to you where? In the first quadrant. راح تعطيك إياه الكالكوليتر. But how you will go back to the third quadrant? You have to go what? Minus pi. you have to add it minus pi, because the calculator will give it to you here. How you will get it here? Just go in this direction, pi. This direction is clockwise, which means minus pi. If both x and y are negative, so tan inverse y على x minus pi. Is it clear here? Of course, I will present it more example now to clarify everything in details, inshallah ta'ala. Okay, is it clear here? طيب خلينا نشوف الاكزامبلز. بيقول لي express this complex number in polar form. In polar form. Here we have z is equal 1 minus 3 square root of 3i. Of course, I have to find first the value of r, which is modulus z, which is the square root of 1 square plus minus square root of 3 square, واللي هو بتساوي square root of 4, which is 2. So the value of r is equal to. الآن the value of x is equal 1, which is greater than 0. والy بدها تساوي minus square root of 3, which is less than 0. In which quadrant this located here? بأي ربع بيقع معي هذا؟ هذا 1 وهذا minus square root. This is in fourth quadrant. Okay? In fourth quadrant. هلا لما يكون معنا بالfourth quadrant, theta, it will be tan inverse y على x, واللي هي tan inverse minus square root of 3, واللي هي minus pi. The calculator will give it to you directly, minus pi over 3, because this number, complex number, located in the fourth quadrant. So no need to add it by or to subtract by. Just take it from the calculator, what the calculator give it to you. طيب الآن the complex number z now will be written as r times cosine theta plus I في sine theta. R2 becomes 2 في cosine minus pi over 3 plus I في sine minus pi over 3. And that's all. You wrote it in polar form. Any question here? هلا simply, just to simplify for you, if your complex number located in the first quadrant or fourth quadrant, theta, it will be just tan inverse y على x. If it is in second quadrant, your complex number, then theta, it will be tan inverse y على x plus pi. بالثird, tan inverse y على x minus pi. Okay? And in case, of course, x is equal 0 and y is equal 0, the complex number, we said that there is no polar form for this one, so it is theta undefined. Why it is undefined? مين بيقول لي ليش undefined?
Because maybe you cannot divide by 0.
Because in this case theta بدها تساوي tan inverse 0 على 0. This value here is undefined value. Anything divided by 0, even 0 by 0 is undefined. Okay. طيب نشوف next example. Write the complex in polar form. هلا x is equal minus 1 which is less than 0 y بدها تساوي 1 which is greater than 0. Where is this one located?
In the second quadrant.
In which quadrant this complex number? Sketch it. Minus 1 مع ال1 here. This is your complex number z. So find the first r, which is square root of 1 plus 1, which is square root of 2. الآن theta, when you do your calculator, the calculator will give it to you in the fourth quadrant. To make it in the second, just added pi. Theta, it will be tan inverse y على x plus pi, which is tan inverse minus 1 plus pi, واللي هي minus pi على 4 plus pi, and theta بدها تساوي معنا ايش؟ 3 pi over 4. إذا البولار فورم now z بده يساوي r, which is the square root of 2 times cosine 3 pi over 4 plus I في sine 3 pi over 4. Okay.
Doctor, should I calculate the x?
Calculate what?
Yeah, like calculate it, the x, calculate and write as an integer numbers.
I don't understand what you mean by your question.
يعني عادي اكتب ارقام ولا اكتبها بالصيغه اللي هي الكوزاين والساين يعني
لا cosine and sine, we need it in polar form, cosine and sine only.
Okay.
Now if you do continue finding cosine and sine for those and multiply it by square root of 2, it will be your complex number, which is minus 1 plus I. طيب الآن compute capital principal argument لل 3 and small argument لل 3. تعالوا خلينا نشوف الآن عشان نصير نفرق ما بين ال principal argument وال شو اسمه. How you can sketch the number 3? 3, the complex number 3, it is here. Go back to this table here. When x is equal 0, y greater than 0, then pi over 2. X is equal 0, y less than 0 minus pi over 2. But here, the complex number z is equal to 3, it's equal to 3 plus 0 في I. Here y is equal 0. The angle theta is equal what? Tan inverse 0 على 3, which is tan inverse 0, 0, because tan of 0, 0. إذن 0 located where? Between minus pi and pi. صح? So the principal argument for the complex number z is equal to 3 is equal 0. But the small argument of the 3, it is equal to principal plus 2 and pi, which is 0 plus 2 and pi, where n is equal 0 minus a plus 1 minus a plus 2 and so on. Is it clear, this example? طيب نشوف البرنسبل argument اللي minus 4. sketch ال minus 4 directly. Where is minus 4? Complex number z is equal minus 4. It is here. Minus 4. So this is the ray. هلا x is negative. طب الآن what's the principal argument? Your principal argument, remember, it should be between minus pi and pi. Now have a look here. If you go counterclockwise, you will get pi. So the principal argument of minus 4 is equal pi. The small argument of minus 4 is equal what? Pi plus 2 and pi, where n is equal 0 minus a plus 1 minus a plus 2 and so on. Okay? Is it clear, this one here?
Yes, Doctor.
طيب نشوف اللي بعدها. راح نشوف more examples later on. بيقول لي البرنسبل argument ل 2i، يعني z بدي يساوي 2i واللي هو 0 plus 2 times i. Sketch it. Where is it 2i? 2 على imaginary part. This is my complex number. And this is the ray. Here x is equal 0, y is greater than 0. So theta, it should be the principal what? Pi over 2. So the principal argument of 2i, that's how we pi over 2. But the small argument of 2i, it becomes what? Pi over 2 plus pi, where n is equal 0 minus a plus 1 minus a plus 2 and so on. So before finding the principal argument or the small argument, sketch it just to make sure where, in which quadrant or where is it the complex number located.
Doctor, why
Yes.
in the smallest argument pi over 2 plus 2n pi or pi only?
2 and pi. Sorry, 2 and pi.
Okay.
Thanks. طيب. So the first part اللي هو البولار form is done. خلينا نشوف الآن الأيلر formula, but of course we will use all the time the polar form. الأيلر Euler's formula, the simple e to the power I theta or exponential of I theta is defined by cosine theta plus I في sine theta. Okay. الآن theta is of course is the angle measured in radian. And again, theta is equal tan inverse of y by x in case z is equal x plus iy. الآن I will use this one, the Euler formula, to rewrite the exponential form of any complex number z. How? Z by using polar form is equal r في cosine theta plus I sine theta. الآن Euler formula says that cosine theta plus I sine theta, it is e to the power I theta. So replace this one by this one. You will get your complex number z can be written as r e to the power I theta, because e to the power I theta is equal cosine theta plus I sine theta. This form here is called the exponential form of the complex number. The exponential form of my complex number. هذا الشكل هو بنسميه exponential form for any complex number z is equal x plus iy. Of course theta هي the principal argument of my complex number z. طيب الآن e to the power minus I theta, logically it is equal e to the power I times minus theta. الآن e to the power I times minus theta, according to the Euler formula, is equal cosine of minus theta plus I phi sine minus theta. But we know that cosine of minus theta is equal what? Cosine theta. صح? And we know that sine of minus theta is equal minus sine theta. الآن cosine of minus theta is equal cosine theta. And I phi sine minus theta is equal minus I sine theta. So that is equal this one. الآن with respect to the concept of conjugate, e to the power I theta conjugate, it means what? Cosine theta plus I sine theta conjugated. Conjugate will change this sign to be negative, صح? But when we change it here to be negative, cosine theta minus I sine theta from the previous equation is equal e to the power minus I theta. So e to the power I theta conjugate is equal what? E to the power minus I theta. Then we conclude that e to the power I theta conjugate is equal e to the power minus I theta. طيب. Further we have cosine theta. It will be e to the power I theta plus e to the power minus I theta divided by 2. But how we get this equation? How? Very simple. Have a look here. E to the power I theta. It is cosine theta plus I phi sine theta. Well, e to the power minus I theta is equal cosine theta minus I phi sine theta. And added those. Added the left hand side, it becomes what? E to the power I theta plus e minus I theta. Cosine theta plus cosine theta بتساوي معنا 2. هلا I sine theta minus I sine theta it will be 0. So you will divide both sides by 2, you will get cosine theta بتساوي e to the power I theta plus e to the power minus I theta divided by 2, which is this equation. هلا the same procedure, you will get this sine theta is equal e to the power I theta minus e to the power minus I theta divided by 2i, not I, not 2 only, 2i. It is the same procedure here. If you multiply e minus I theta by negative, you will get this positive and this negative, and just added you will get 2i in the denominator. طيب نشوف الآن بيقول لي compute e to the power pi I. How we can compute this one? Very straightforward. Just a minute. Shall I just connect the cable for the power? الآن e to the power pi I, according to the Euler formula, e to the power pi I, it will becomes cosine pi plus I في sine الباي. Cosine الباي is equal -1 plus I في sine الباي, it is 0. So e to the power pi I is equal 1. Okay? طيب. الآن there is an identity for Euler is equal -1, sorry, here. If you take -1 to the other side, it becomes e to the power pi I plus 1 is equal 0. This is Euler identity. Why? Because according to the Euler formula, e to the power pi I is equal -1. طيب. الآن we will see some examples for writing the exponential form of a complex number. We have here the complex number z is equal -1 minus I. -1 minus I. He said write it in exponential form. الآن I mean I have to write z to be r e to the power I theta. This is the exponential form. First of all, I have to find r. R, it will be square root of -1 square plus also -1 square واللي هي square root of 2. الآن where is, how we can find theta? Where is this complex number located? -1 with -1, it is here in the third quadrant. So theta, it will be tan inverse y على x minus I. برافو عليك. Exactly. Which is tan inverse of -1 على -1 minus pi واللي هي عبارة عن tan inverse ال1 minus pi واللي هي pi على 4 minus pi واللي هي minus 3 pi over 4. إذا الكومبلكس نمبر z it becomes r e to the power I theta بدي يصير معنا عبارة عن square root of 2 e to the power minus 3 pi over 4 times I. ايش الباور مش راضي يشتغل. أعوذ بالله من الشيطان. استغفر الله العظيم. اوكي طيب نشوف another example. أقول لي write the complex number minus I in exponential form. And the Z is equal minus I. Where is minus I? Which is here is equal 0 plus I في minus 1. The exponential the complex number already here located now. This one here, minus 1. So, how you will find the argument? Theta بدها تساوي what? You will go this way, which is minus pi over 2. راح تكون معنا كم؟ minus pi over 2. Theta is equal minus pi over 2. R تساوي square root of 0 square plus minus 1 square, which is equal 1. واللي هي already modulus Z. الآن the complex number Z becomes R e to the power I theta, واللي هي عبارة عن 1 times e to the power minus pi over 2 times I, which is e to the power minus pi over 2 times I. So this complex number minus I. طيب خلينا نشوف in case I have it as a real number and I will use the complex form, the formula of complex number. Where is the number 4? العدد 4 وين بده يجيني؟ As a complex number in the complex plane. 4 من الx's, this is 4, this is my complex number here. الآن how you will find theta? Theta, there is no theta between the theta between this ray and the x-axis, it is 0. R بدها تساوي because in the Z is equal 4 plus 0 times I. R بدها تساوي modulus Z, which is the square root of 4 square plus 0 square, which is 4. إذن 4 it is my complex number, which is equal R e to the power I theta, which is equal 4 times e to the power I times 0. طب I times 0 is 0. e to the power 0 1 times 4 بيعطيني 4. Is it clear here?
Yes, that's good.
طيب. We will go now to the multiplication and division of complex number by using the exponential form, and how we can find the principal argument or the small argument for any one of those numbers when we multiplied or divide. هلا الpolar form of a complex number, we will use it, the exponential form, to find or to define the product of multiplication and division of two complex numbers. If I have the first complex number Z1 written in the form R1 e to the power I theta 1, Z2 is equal R2 e to the power I theta 2, then Z1 times Z2, it will be R1 times R2 e to the power I theta 1 plus theta 2. Z1 divided by Z2 is equal Z1 R1 divided by R2 times e to the power I theta 1 minus theta 2. But why this is correct? From where we get these equations? Now when we multiplied R1 e to the power I theta 1 times R2 e to the power I theta 2, this is becomes R1 times R2. هلا البيز are unified, which is E, so you have to add the powers, which is e to the power I في theta 1 plus theta 2, which is this one here. A division also the same procedure. When you divide, you divide exponent by exponent, you just divide the power, subtract the powers, so you will get this one. From those two equations, you can conclude a very nice remark. What that remark is? Remember that theta 1 is the argument of Z1. Theta 2 is the argument of Z2. Okay? الآن, the argument of Z1 multiple Z2 is this angle, which is theta 1 زائد theta 2. What does this mean? That means the argument for Z1 multiplied Z2 is equal theta 1 plus theta 2. But theta 1 is what? Argument of Z1. Theta 2 is equal what? Argument of Z2. Okay? Also, from this equation here, what you conclude? R1 times R2. R1, it was modulus Z1. R2, modulus Z2. The modulus for Z1 times Z2, it is R1 times R2, which is equal modulus Z1 times Z2. And the same thing you can conclude it from here. The argument for this complex number Z1 divided by Z2, it is theta 1 minus theta 2. But theta 1 is what? Argument Z1 minus theta 2, which is argument Z2. Type. The same procedure. الموديولس لZ1 على Z2 is equal what? R1 divided by R2. But R1 what? It is modulus Z1. Well, R2, it is modulus Z2. And this one here is clearly from this graph. This is the complex number Z1. It has theta 1. Or Z2, it has theta 2. هلا Z1 زائد Z2, it will be this way, in this direction, and this vector. So this angle here, it will be theta 1 plus theta 2. You will get the argument for Z1 and Z2 times Z2. Is it clear here? Is it clear? واضح؟
Yes.
طيب نشوف الآن الباور, how we can find the power for complex numbers. Integer power of Z, I mean integer power of any complex number. If you have the complex number Z, written in its polar form, r cosine theta plus r sine theta, or exponential, which is r e to the power I theta. هلا z to the power n, it becomes what? R cosine theta plus I sine theta to the power n. Now when you distribute the power now, it becomes R e to the power I theta. This power here n, it should be once go to R and the other one multiplied by what? By theta. So it becomes R to the power n e to the power I n theta. But according to the Euler formula again, r to the power n e to the power I n is equal what? R to the power n times cosine n theta plus I phi sine n theta. Is it clear here? Z to the power n integer, it is equal r to the power n cosine n theta plus I phi sine n theta. What's the benefit of this equation? Sometimes I will ask you z to the power 1000. In this case, you will spend around 3 to 4 days to find or to multiply this complex number by itself 1000 times. But using this inequality, it becomes r to the power 1000 phi cosine 1000 theta plus I phi sine 1000 theta, which is very straightforward. Like this number, he said compute z to the power 3, where this is the complex number z. First of all, I have to write it in its exponential form. I mean, I have to find out the value of theta. هلا r, it will be mod plus z, which is the square root of 1 square minus the square root of 3 square, which is 2. Now we need theta. Theta. Where is this number located? In which quadrant? ال1 وهذا الماينس square root here هون. Somewhere here. بالfourth quadrant. Theta, we calculated it is equal tan inverse minus the square root over 3, which is minus pi over 3. واللي هي this angle minus pi over 3. هلا z to the power 3 عبارة عن ايش؟ عبارة عن 2 e to the power minus pi over 3 في I to the power 3. To the power 3, which is equal to the power 3 times e to the power minus pi over 3 times 3 في I, واللي هي 2 to the power 3 عبارة عن 8 في e to the power minus pi I، واللي هي عبارة عن 8 في كوزين الباي زائد I في ساين الباي، which is equal 8 times minus 1 زائد I في 0, which is minus 8. Now if you go and multiply it manually, 1 minus the square root over 3 times I by itself 3 times, you will get the same value, minus 8. I think I have a problem with my cable of my computer, sorry. Maybe we will running out the battery soon. طيب. الآن, let us do this example only. Z to the power minus 4, Z is equal to 1 plus I. Here z is equal 1 plus I. First of all, find r, which is the square root of 1 plus 1, which is square root of 2. الآن, where is this number 1 plus I? Here, this in the first quadrant. Theta, it will be tan inverse 1, which is pi over 4. هلا z راح يصبح معنا 1 plus I in exponential form بتساوي r e to the power I theta واللي هو square root of 2 في e to the power I في pi over 4. هلا z to the power minus 4 بده يساوي square root of 2 to the power minus 4 e to the power I pi over 4 times minus 4 واللي هي بدها تساوي 1 square root of 2 to the power minus 4 في e to the power I في minus pi. Okay? And you can calculate this is becomes 1 على square root of 2 to the power 4 times e to the power minus pi is equal 1 minus 1, sorry, which is equal here minus 1 على 4. So this value is equal minus 1 by 4. I have to stop here to fix up the issue on my computer. But I still have 3 minutes in my lecture. I will add the 3 minutes next time, inshallah ta'ala. Let us to take the attendance, please. Take the attendance.
What is the code, Doctor? Yes. Yes, wait. I think he would back.
Can you enter the code, please, for the attendance?